young math padawans. It's Mrs. Angel with your lesson for today on describing and creating variable expressions. So before watching this lesson, make sure that you've had a conversation with your teacher about what a variable is and different examples of a variable expression. This is broken up into two parts: describing variable expressions, sum, difference, product, quotient, etc., and then also creating variable expressions given a specific criteria and some words and phrases. So make sure you have your workbooks opened up to Unit 5, pages 2 and 3, and let's get started. So now that we've seen some examples and we've talked about the specific roles of variables, let's actually go into this practice. So if we read the directions here, I'm going to zoom in a little bit. First, we're asked to classify as a sum, difference, product, or quotient. I feel like we're pretty good at that at this point, especially coming out of Unit 2. Then we have to determine if the variable is a term in a sum or a difference, like we had in our first two examples in this table, a factor in a product, like we did in that third example, or a numerator or a denominator in a quotient. So in other words, we're looking at the expression as a whole, and we're classifying it, and then we're zooming in to just the variable, and we're trying to figure out what role is it playing. So let's look at these examples. So if I look at example 1, this is clearly a sum because I see x plus 5. But then if I zoom in and I look at just x, I see x is on its own. It's its own term in this sum. So that's why we were able to say that this variable is a term in the sum. That's the specific role that it's playing. It's its own term. In the second example, however, it's still a sum because we have that addition sign outside of parentheses. We would read this as 3x plus 5. So it is a sum, but if I zoom in on the variable, wait a minute, this variable is now part of a more complex term. X is now being multiplied by 3. So the role of x has changed. X is no longer its own term. Now it's a factor in the product 3x. And that's the difference here. In this second example, the variable is a factor in a product, and that product is a term in the sum. So you have to step back and look at the whole expression, but then you can zoom in to really just see what that variable is doing. So now that we've gone over both examples, I think that you're capable of doing this page on your own. So go ahead and start with 1 through 4. I'll show you those answers, and then we'll move on to 5 through 8. How did you do? So looking at number 1, this is a difference, and H is alone, so it's a term in the difference. Number 2 is a product, even though you don't see parentheses, and M is attached to the coefficient 9, making it a factor in this product. Number 3 is a quotient because of the fraction bar, and since J is in the top, J is the numerator in this quotient. And number 4, 5 divided by P is a quotient, but this time the variable P is in the bottom, making it the denominator in the quotient. Now 1 through 4 are all pretty simple expressions because they only have one operation. We don't have mixed operations. So when you try 5 through 6, be careful because like the second example we went over, now there's mixed operations, multiplication and subtraction, multiplication and addition. So you have to pay close attention to the structure of the expression and the role of the variable. So go ahead and try 5 through 6, or excuse me, go ahead and try 5 through 8 on your own now. Let's see how you did. Now remember, these were a little tougher because they had different operations. So I'm going to go through these. Number 5, we would classify as a difference. But in this case, the variable is a factor in a product. Because when we zoom in here, the variable is part of this term 4k. 4k is a product, 4 times k, and k in this case is playing the role of a factor. So even though this classifies as a difference, the variable in this case is a factor in the product. That's also a term in the difference. In number 6, this would classify as a product 2 times the group x plus 5. But again, if we zoom in here, the variable is part of this group, the variable is part of this group, x plus 5. X plus 5 is a sum. So really here, the variable represents a term in this sum, and that's where its role comes from. It's a term in a sum, and that sum happens to be a part of the product. In number 7, this would classify as a quotient, but if you zoom in here to where the variable is, I see y plus 3 in the numerator. But y here isn't a numerator, it's part of a sum, y plus 3. So here, y is its own term. Y plus 3 is a term in a sum. That sum is part of the overall quotient. And finally, in number 8, the classification is a product, but the variable is a term and a difference. Because if you zoom in here, the variable is part of this group, 12 minus x. And that means it's part of a difference, and since it's standing on its own, that makes it a term in the difference. That difference is part of the overall product. So when you're looking at mixed operations, and the more we get into this, it's helpful to realize what the entire expression is, but then specifically what's happening to that variable. So we're going to wrap up this video just looking at creating variable expressions. Now that we've looked at variable expressions that are sum, differences, products, and quotients, we're going to go in and find some words or phrases that actually represent those different expressions. So the way that we're going to do this is we're actually not going to write the expressions. We're just going to add the words and phrases from this table into our table at the top here. So what words or phrases do we have that represent a sum, a difference, a product, and a quotient? So to find this, we're going to look at some examples. So the word or phrase that represents the operation or the expression are basically everything outside of the number and the variable. So in this one, I see 3 more than x. So 3 obviously represents the number 3, and x represents the variable. So what are the other words here? The words here are more than. So now I just have to figure out, well, what does more than mean? Does more than mean adding, subtracting, multiplying, or dividing? What do you think it means? If you said more than means adding, you are correct. More than is one way to represent a sum. If you say 3 more than 5, that means add 3 onto 5, and so on and so forth. Let's find some more. In number 2, x less than 10. Well, the phrase here, because x is x and 10 is 10, is the phrase less than. What do you think less than means? If you said less than means subtraction, you are correct, because less is the opposite of more and subtract is the opposite of add. So less than is a way to represent a difference. Let's do 2 more together. Number 3, 3/4 of x. Ooh, what's the word here? The word is of. What do we think of means? Well, this is a tough one, but if I think about it in a different sense, if I had 2 of something or 10 of something or 12 of something, that's like taking that thing and multiplying it by the number of groups I have. What did I just say? Multiply? Actually, yes. Of means multiplication. So we can write of in our product box. Last one we do together before you try some of these on your own. Ooh, number 4 is an interesting one. We have 2, and there's more than again. More than means adding. 2 more than 3. There's a second word here. The second word is times. So there's actually 2 operations happening here. So we have more than, which means adding, but times represents multiplication. So the word times is another way to represent a product. All right, time for you to finish out this table. Go through 5 through 10, highlight the words or underline the words that represent the operation, and then you might be able to add more phrases and words to your table at the top. Great, so I went through and highlighted all of the words. And it looks like the only words that we could add to our table were the sum of and decrease by. Everything else was a repeat. So now let's go in and actually create these expressions based on what the words are telling us. Number 1, 3 more than x. Okay? Some of you might be thinking this means 3 plus x. And you're close, but not quite. More than means it's happening to X, which means X is actually your starting value, and 3 more than is the change. So really think of it like this. This phrase 3 more than is a change that is happening to X. And if we remember about starts and changes, the starting value is the first value in your expression. So we would actually write this as X plus 3. The word than means that's a change that's happening to that value. X plus 3, and we would classify that. Well, we already knew that. More than means we're working at a sum. Okay, let's look at number 2. X less than 10. Ooh, again, you're like, oh, less than, that means subtraction. That must mean this. But than means that's the change. So actually, X less than is the change that's happening to the starting value of 10. So less than means take away from. So this really means X taken away from 10. So the real way to write this expression would be 10 minus X. That's X less than 10. And we already knew less than is how we describe a difference. Let's do the next 2, and then you can do the rest on your own. 3/4 of X. Now, we already know of means multiplication, so you might be thinking 3/4 multiply X. But do you remember about products and coefficients? Do we need those parentheses there? We don't. So we could just write this 3/4 of X as 3/4 X. No parentheses, dots, or X's needed to show that that's multiplication. In this case, 3/4 is our coefficient in this product. Last one we do together, because now we're going to start mixing and matching. Okay, 2 more than 3 times X. Let's break this down. Well, we know what 2 more than means. More than means a change. So this is a change. 2 more than something. So we're going to be adding 2 onto something. What's our starting value? Well, our starting value is this whole expression. We're adding on 2 to the expression 3 times X. So let's work backwards here. So here the starting value is 3X. 2 more than that means I'm adding 2 onto 3X. Now this has a mixture of multiplication and addition, but how would we classify the whole expression? This would be a sum because that addition is outside of parentheses. Why don't you try the next ones on your own? Great effort, Math Padawans. You'll go over those with your teachers later on. Let's recap some of the important vocabulary that we learned from today. So first, we talked about a variable. Variables are symbols that represent unknown values, and that will start to make more sense as we get into evaluating expressions and solving equations. Coefficient was a new word that we learned today. The coefficient is a number that is multiplied by a variable. So in these examples, in 2x, -6y, and 2/3 m, the coefficients are 2, -6, and 2/3, because those are the numbers being multiplied by variables. Notice also, all of these are products, even though they don't have parentheses. And then finally, this is going to be a little bit tough, but whenever you see the word than, more than and less than, these represent changes. So when we say 2 more than C, that means C plus 2, not 2 plus C. That's it for today's lesson. I will see you next time.